digital pathology, followed by some introduction about the neural network, and then we have called application of deep learning architecture in healthcare in a broader aspects, followed by then some data set which could be used for medical field, and then the deep learning architecture for classification of liver cancer grades, or predicting the liver cancer this severity as well, right? And last few slides will be glimpses about the healthcare at NDK, followed by the few research directions. So, if you are the beginner, so you cannot directly jump into the field, in the field of AI/ML or in the field of deep learning. So, for the prerequisite, for the deep learning algorithms, model, architectures, right? You should have two important things here as a prerequisite. That's called domain technical knowledge, followed by the next is a software skill, software and hardware skill, right? In a domain technical knowledge, you should require linear algebra, probability statistics, fundamental image processing, fundamental of computer vision, strong foundation on DNA, and then the core subjects. Now, question here is why domain technical knowledge is necessary? Domain technical knowledge is necessary to formulate a right problem statement of your project work. That means, suppose you want to take up your major project or any project, right? In the area of medical image processing or healthcare in general. Who can give you the right problem statement? You want looking a good problem statement. Who will give you the right problem statement? Source of problem statement comes from the hospital, medical colleges. So the first step should be try to visit in the hospital, nearby hospitals like KMC, Bangalore, right? AJ Medical College, your itself Srinivas Medical College there in Suratkal, and then your AJ, then Fatherullah, right? So lot more hospitals are there in the Bangalore city itself, right? So if you talk to the visit hospitals, talk to the different departments, which if you go to hospital, right, you see there is a called radiology department. So most of the data analysis comes from the radiology department, right? Where your CT scan, MRI, X-ray, mammography, ultrasound, right? All the data comes for the major data. Major available data is from the radiology department, right? Then you can go to the ENT, cardiology department, you see ECG, right? Mainly for cardio ECG they will do that, and then angiography, all things comes from there. Then you go to the other department, neuro department, EEG you see that. Then go to the ophthalmology department, retinal data, go to the skin department, dermos images, right? So if you visit different departments, you can get the different problem statements, right? All the problem statement related to human body, right? So that's very important. Once you have a right problem statement of your project in your hand, right? Then roles come as a software developer, right? Engineers, right? So, but if you do not have a right problem statement, you as a computer science engineer, what you are going to do? What you will code? You are clueless. Okay? So problem statement is a first stage which decides the quality of your project work. In my lectures, I will be mainly focusing on the project work, right? Because project is the work which decides your future. If you do good project, right, and project is good, and then you will struggle also to complete the project. But if you struggle, a moment project get completed, that will help you, getting a good job placement as well, right? So that's one part. So problem statement already done by domain technical knowledge, right? For example, this case, if as per the keynote speech, advanced deep learning algorithms for liver cancer severity grading from histopathology, right? So what is the problem statement? Design and development of, right, enhanced deep learning algorithms for liver cancer severity grading from histopathology. This is a problem statement, right? And then you can frame the multiple objectives, at least two objectives of your project, right? First objective would be like simulation and performance evaluation of existing, deep learning algorithms for liver cancer grading from histopathology images. Second objective would be to propose, right? To propose an efficient and effective deep learning or robust deep learning, whatever keywords you can frame that. So two keywords, two as a project objectives. Once done, project title, problem statement, research objective, project objective, then you have in good conditions. Now start, making the solutions, completing the objectives. So to come up with the solutions of the whatever the problem you have formulated or the project given by the domain expert like doctor, specialist, then you need a software skill and hardware skill. Software skills, you need a Python programming, all the packages, Panda library, SciPy, right, NumPy, all that you need to have your good hands-on experience, right? And then OpenCV library, and then Scikit library. Scikit library, again, very powerful for using the data, pre-processing. Then lot of the basic, machine learning algorithms are already available. You can those algorithms can be used Scikit library for quantifying, machine learning and deep learning algorithms as well. And then your deep learning libraries like your Keras, TensorFlow, and then your PyTorch, right? So this is what the required for development of the algorithms, right? Whatever the deep learning. So if you are developing deep learning algorithms, so you need a deep learning framework, packages, TensorFlow or PyTorch, right? Then it's not only just developing that, you have to go for the deployment also, maybe hardware. As my objective, I told you intention should make as a end-to-end product, right? So either you go hardware side or go to the web-based app develop. Make it complete as a package, right? Product here. So you can develop as a web-based app. For that you need Flash, other Hugging Face, all you need expertise, all the things for developing web-based app. But if you're looking hardware further on this AI on edge devices, right? Then Raspberry Pi, NVIDIA Jetson Nano board, FPGA again required. That's why see, interdisciplinary only give you the good projects. Because if you want to do on FPGA other things, being computer science guys, you cannot do that. You need to talk to the EMC people, right? Because they are using all the boards, right? Develop the software part, give it to them, interfacing all together, you can make as a product form, right? I hope it's clear. This slides is very important as far as as a basic requirement is concerned in the deep learning field, right? Now, moving ahead, these three keywords already you are aware of that. I'm not going to talk. AI, ML, DL, all the things. Come to over here. So that's called healthcare data format. So if you see healthcare data, right? So data are 1D healthcare data, 2D healthcare data, 3D healthcare data, right? Which are available. All the data comes from the human body, right? And from different sensors, right? So right side see the anatomy of the human, right? And here See, our human body, upper part is most important. I say every part of the human body is important, but upper part of the human body is the most important, right? For the survival, for living good life, right? So like your heart, kidney, liver, right? So stomach, these are the important organs, right? Which, brains, right? All the way most important organ. Suppose your leg is got fractures, right? Leg is got fracture and even leg is not there. Still you can do wonders, right? Still you can do wonders if you don't have one leg, right? If you don't have one hand also, still you can do that. If the right hand is there, you can do many things, right? So that's it. But keep in mind that what are the most, organs that you need to take care, right? But nowadays, everyone busy in the digital era. Now we are in digital era, right? If somebody steal your mobile phone for 1 hour, you become very what I would say that, right? Mobile is not there. Anxiety start coming. Where is my phone? What they phone will be coming, message will be coming. That's what they right. That should not happen. Try to in a daytime. Try to away from at least 1 or 2 hours from mobile phone. Okay. So here you see that heart, liver, stomach, kidney, right? And then bladder, intestines, lung, brain, right? So these are the important topics. So my focus is what? This 2-year talk is on the liver part, right? How the deep learning could be used for the cancer grading or the liver cancer severity grading from the histopathology images of the liver organ. Okay. This is the histopathology image, which is called 2-dimensional image, right? And this is most important pathology department, right? So if person is got cancerous, right? So the label of cancer, the grading of a cancer has to be done by the pathologist, right? And currently the pathologists, they require 1 week time to generate a report on the any tissue imaging, right? Any like affected organ. So 1 week time, how can we minimize into at least 3 days, right? Because the cancer is so sensitive disease, which is very essential. Early diagnosing is very important, right? So staging is must, has to be done as early, that will be save the life of a person as well. So here you see there is called blue color, some circle, then pink color, right? You may not understand right now, right? But try to understand after the conference, right? Now, what is histopathology in more detail, right? So one is called nuclea. So whatever the circle you see, blue color, that's called nuclea, and rest we call as a cytoplasm, right? So if the cell, like if an organ is like cancerous, the color, shape and size of the nuclea get changed. That's how the pathologists see the nuclea shape, and they also look at the cytoplasm, also other regions as well, right? So that's how they will analyze by the eyes under the microscopy. That's why definition is here written. Is the diagnosis study of a disease of the tissue under microscopy. So they are doing analysis using the microscopy, but how the microscopy, right? The usage of the microscopy can be minimized by using the AI algorithm. That's what the role is. Intention is that. And of course, that will go for the various clinical medicines, all the things. This is the complete setup you see here. This is a specimen, right? That's a millimeter tissue of an infected organ, human organ, right? And then goes to prepare glass slide, and then you can give, this is a microscopy, And then this slides you can give it to the called slide scanner. So here you see there is a space, right? This slide you can insert inside. Okay. Then this will be interfaced with the computer. So you will get this type of, that's called whole slide imaging, WSI. And this image you can keep it here bottom of this, and from the top you can see that, and there is a facility to zoom as well, right? You can zoom that, you can capture the region of interest, right? From this microscopy. So various type of microscopy are there, Olympus and Nikon and so on, Filian and so on, right? So this will be helpful for looking the different zooming. Zoom, I hope you understand, right? So magnifying, they magnify the region of interest. Is there any change in the color, shape and size of the nuclei? Right? That's how they will identify. Now next topic is little bit talk, right, as a teaching machine to interpret medical image, right? What we see and what computers see both are different thing, right? So here you see that this is what we are looking as an image, right? But computers see, understand only the numbers, right? So here this is see that is called RGB image, and here they see that RGB works in the additive mode. Red, blue, green, RGB, red, green and blue bands, right? 3 bands, right? So portion of R, portion of G and portion of V, add it, that's what you see as a pixel value here, right? These are intrinsic values, okay? Likewise, if you say there's a medical data which is called MRI, and here if you see MRI, you can see red channel, green channel and blue channels here. And particular number if you see here, that's called decimal number 34, which we call as a intensive value, right? And this decimal number has to convert into a binary, right? 8-bit, okay? So 8-bit representative you can see here. So if you want to store the data, right, into the system, right, the number has to convert into digital number, right? Which already you are familiar of that. How to do convergence, right? And you can see here if you give the input data, right? Algorithms can detect tumor, and then tumor may be cancerous, maybe non-cancerous. If you get a tumor is there any part of the body, no afraid, should not be cancerous. If it non-cancerous, can be cut and removed, nothing will happen, right? Okay, but why become cancerous? Because of if it goes too long inside that, then non-cancerous get converted into the cancerous, right? So that's why some of the tests keep on checking that called annual health checkup is necessary to avoid any future complications. So you see that one is called brain tumor detections you see here, and then other is called different the gradings of the brain abnormalities, like normal medical data algorithm, normal grade 1 to 4 you can do. That's called, these are grades, nothing, these are called severity, right? Grade 1 is person is early detections, right? Grade 2 little more. Grade 3 and 4. 4 means very rarely people will be the life can be saved, right? So that's called high severity, right? Okay. So 3 and 4 are that's come into the high severity cancer gradings, okay? Where the first and second low severity, you can keep that, correct? So 1 and 2, that can be treated with the medicines and with the lifestyle changes and all foods and everything, okay? So now the role of how the medical data, AI, everything play in the same role here. So if you see here, data analyst, which like AI, ML people or computer science, and the medical expert, right? And here they call medical clinical domain. So everyone, medical domain, AI expert, right? And then even the medical other domain, everyone work in as a team. Unless if you work as a team, you cannot build a solution. So if you want to make a complete automation system, automation tool, decision support system, like medical decision support system, then every role of the pathologist, other specialists, role of the engineering background, AI, ML, every data analysis is important and work in a team so that a good solutions can be developed, right? That's what indigenous, right? This other part you see that is called, top rows, A that indicates the images without tumor, and bottom is say that, with the tumor image, right? That's called brain tumor, right? MRI image, right? This again, there is tumor, there are different type of the tumors are there. Sometimes 15 subtype is there, 45 subtypes there, subclassic go for, so it's very, data set already available, right? So you can find out later on as well, right? So you give the algorithm, will tell that tumor detected, what type tumor, like it is classification task, right? Here. So if you see that first A is, initial stage, B is called gloma, and other type of different type of brain tumor, you can classify that. Classification task, right? Not detecting that inside what is there. So classification followed by the, how many have heard you the segmentation? Have you heard about the image segmentation? Okay. So in image processing, that very important concept called image segmentation. So here nothing, if you want to detect, where exactly brain tumor is there. So you have to go for the segmentation task, right? So for segmentation, you can also use the deep learning algorithms as well here. So you can see here, right? These are the input images, these are the brain tumor regions. I would say that this is a ground tooth. Next column is a ground tooth. The last column is the predicted image by the algorithm here, right? So you see that this is not as accurate as the ground tooth is there, right? That's part. Then you can do the retinal disease detection as well. So your machine AI-based solutions can detect the retinal images. So retinal images are also very different types. If you see here, start from here, there are different type of the humor retinal images diseases are there, right? So you can classify what type of humor retinal image there. So for that, you have to visit to the ophthalmology department in the hospital, right? Okay, you can do that here. And then you also have called OCT, this is called fundus images, right? Diabetic retinopathy detection, all things happen over there. And then you can go for even the OCT, optical tomography image, that will be used for retinal disease detection here. So here you see 4, this is normal, and other 3 subtype of the retinal disease that is used for the classification task. So for this also you can use the deep learning algorithms or advanced deep learning algorithm, right? Can be classifying the retinal disease, right? Okay. Now coming to the digital pathology. So digital pathology as here is very important, like improved workflow in the laboratory. Like if you are using the digital pathology, that the image can be saved from one hospital to other hospital. Like if from in the same city, inter-hospitals, inter-city, inter-states, even for the other country as well, right? So through cloud. How will we save that? The data through cloud, right? So the data will be uploaded cloud. Like simple, your Google Drive. You're putting data in Google Drive and you are sharing to your friends, right? Nowadays you may be doing more sharing the pictures, keeping drive and all your party pictures, right? Now that's same that, right? Now you start up sharing that in Drive, start developing the algorithms. You can share to the other your friends codes, data set in your Google Drive and just share that, okay? Anyone can see that, right? So this is what let's improve the workflow in the laboratory, and then solutions to shortage of pathologists. Wherever there is shortage of pathologists, no worry, right? Rest everything done by the local technician, lab technicians. Okay? Normally those who do the BSc, pathology, some radiology, all things, laboratory technicians, they can do all the tasks. They can upload data to the cloud, and doctor who's sitting in US, he can analyze the image, data, right? That's what the power of digital nowadays, purpose. So make easier to save the cases between multiple pathologies, as well as second opinion can be sought, which may help to improve the overall quality of the healthcare service. So data, if available cloud, anyone can access, can be downloaded, can read, can take, give opinions. So cloud and digital pathology and cloud-based services, integrating these two, that help improve the healthcare services. So these are the advantages of digital pathology. That's called portability, ease of sharing, retrieval of archival images, ability to make use of computer-aided diagnostic tool like image algorithms, increase productivity. Of course, if digital image is there and scanner is there, tools are there, instead of doing the manual things, put down the scanner, give you the digital image very quickly, right? And a whole image can be shared to the other pathologists, other hospital as well. Why to use digital slides? Right? Digital slides are essentials for various applications, even in classroom teaching. Classroom teaching only, not for us, engineering. This is important for the medicos, basically for MBBS, when they do the courses in like second year, pathology courses. For them teaching will be good for them. Research and pharma, like I'm using pathology for my research, right? So that could be used that. And then publications, doing good publications, telepathology, teleconsultations, primary diagnostics. That's how digital pathology digital slides will help you, right? This is the complete, if you see that flow. Top is called radiology, patient is scan film radiologist, right? And whereas if you see the pathologist, tissue, lab, slides and pathology, right? So you can see over here in pathology, right? The analysis will be done by the pathologist, whereas if you have the, other medical images which will be done by the radiologist, right? This is how the complete steps which pathologists will be using for, preparing the digital slides. You have seen the glass slides, right? Started from here, this is what? This part already you have seen. I think this you have seen that, right? This is step. So from here to here to here, there is a steps pathologist has to follow. What is step they have to follow? Tissue collections, fixation, embedding, sectioning, deparaffin, staining, and then glass slide, right? So you as an engineer, as an AI ML, you need not to bother these steps. That's not your role. This is a pathologist's role. They will do that, okay? So there are different type of digital slide scanners are there. Started from this Olympus, Nikon, Carl Zeiss, Hamamatsu. So what I suggest here, Aperio, Hamamatsu, Aperio, these are the, Aperio is a brand of Leica only. These are together only. So there are good, and 3D histech that which you have seen that this is a 3D histech, right? This company, right? Scanner. So these the scanners, they have single slide scanner, multiple slide scanners. Even this you can put 50 slides at a time. So technology is very fast nowadays. But of course, buying a scanner is not, is a costly affair because you have to spend crores of money even this if you are going for more than one slide scanner. One slide scanner itself it costs around 40 lakhs, right? So if you are going 5 lakhs, so you have to spend around 1.5 crores to get the scanning for that purpose. This is just this is scanner that will be used for that. Hamamatsu actually. So they are using the nano zoomers for histopathology images. This is Aperio that's uses for the, here you see these are the racks, So here we'll be putting the slides in the Leica company. And this is very good actually. This Aperio CS2 is that's give you the high quality digital slides, which is very good for the digital pathology applications, and many good hospitals they are using, especially if you go to AIMS hospital, you will find the scanners, right? AIMS, Delhi or other AIMS hospitals, you find this kind of scanners are available in pathology department. But in fact, even that KMC doesn't have high quality of a scanner. But still now they have some medium point of quality scanners, case slide scanners. This 3D sticks, and of course. This let's skip. So now, just one slide about neural network. So if you see the neural network here, your journey should start from the ANN, right? Start journey from ANN, reading, writing, coding, implementation using the deep learning software, TensorFlow or PyTorch. Start from here, right? ANN, DNN, CNN, RNN. Blue colors is the foundation, fundamentals, right? Being AI/ML, being computer science, we should be knowing all these steps, right? And then after that goes to here the generative adversarial network, GAN, graph network, vision network. So these are basically advanced concepts. So as I told you, basic deep learning, advanced deep learning, right? So start from here, graph network, all things that start your the advanced concept. Your ChatGPT, DeepSeek, these are nothing, these are just Gen AI model, LLM models, large language models, right? Those models are the built with the advanced algorithms, advanced AI, okay? So coming to the architecture which are most frequently used for the classification task or grading task could be used. LeanNet 5, start from that, AlexNet, VG16, GoogleNet, InceptionNet, ResNet, DenseNet, Inception, ResNet. These are called classical deep learning algorithms for the classification task, right? Image based, like grading if you want to do. Yes or no task, cancerous, non-cancerous. Cancerous, what level of cancer is there? Like grade 1, 2, 3, 4, normal, all kind of the tasks. These models can help you to do that. But these are the already available models, right? That's called standard deep learning models, which you can use in library, API, you can build, you can get that. But ultimately, that's not enough. You have to go beyond that. That's called, you have to develop some called enhanced deep learning algorithms. That's called advanced deep learning algorithm. So that give you the best result on multiple data sets. That's what your objective should be. This model, I hope you are aware of that LeanNet 5 for the classification task on the image data set. And this is what AlexNet is the breakthrough start from here. After this, mainly the breakthrough work carried out in the era of after this. So 15, 16, 17, these three era was breakthrough eras, where all the good models like segmentation, other classification, and then the GPT, all things started in that time only. So you can see that part. Now moving ahead quickly on application side. So let's talk about the major applications of deep learning. So start from the broader as a field, signal processing, image, healthcare, and then other field you see that listed here. And this you can see in a pharma industry, that a lot more applications using AI. So you can use advanced AI algorithms as well. So as applications in healthcare field, you can do either object segmentation or you can do the object classification, right? So which you can see single object segmentation from medical data, multiple object segmentation from medical data, CAD system, classification of tumor, not tumor from medical data, right? And then classification of subtype of cancer from the medical data. This is in general, right? So you can go for the, more specific. So whatever the task, whatever you do in AI/ML field or data analysis belongs to either of any one class in this family, right? So normally you will come up with called, either doing regression task, right? Regression task in the sense that, right? You'll be designing a model or developing a model which will be predicting a real value quantity. What do you mean by real value quantity? Always model giving you the numbers, right? That's called the regression task. Best example you not forget. Take your facial image, your face image, give it to AI algorithms, and tell algorithm predict the age of mine, age of a person, right? So age of a person is a number, right? Which is a real value quantity, right? So that's called the regression task, right? If your agriculture background predicting the crop yield, any crop yield is another example of the regression task, right? So basically anything in the model is giving the numbers, right? Which is greater than 0 and less than infinity, right? In between, greater than 0, right? And less than infinity, right? But greater than 0 in the sense that, but should be integer, either not like 0.5. If you say 0.5, right? It's not, I'm like that. It's like more than 1, right? Closer to that, right? So then coming to binary classification. So binary classification is a problem where you will be predicting either yes and no task, right? One class of the two classes. Again, take your facial image, give input to the AI algorithm, and tell that predict me my gender. So either male or female, right? So that's again example. So that's called binary classification. Like that in medical field, cancerous, non-cancerous you can do, right? You can do tasks. Likewise, other field can be also expanded. Then multi-class problem where you are going to predict the more than 2 classes, right? Like for example, cancer grading. So cancer grading like normal, grade 1, 2, 3, 4. So give input data one image, it will tell whether this input image is a normal or it's a cancerous, or a grade 1 or grade 2, right? That's called multi-class classification, right? That basket would be combination of among these, right? Means regression can be combined with the classifications, right? That could be called use. So if you are building a AI models from facial data, so your model, you will be incorporating both the tasks because input is the same. From one input data, you will be predicting 2 output, right? One output for the age of a person, and second output will be the gender, right? So you will be combining the 2 tasks, right? That's called regression as well as a classification task, right? Likewise, those who do object detection also combines the 2 tasks, classification as well as regression, both the things, right? So these are the examples of the regression task. If you just see that. Time is short, so I'll move a little fast here. So these are the list of examples which belongs to the, as a regression task in medical field. As a fusion, bone age estimation from hand X-ray, lung age estimation, brain age estimation, de-speckling, contrast enhancement. I hope you can understand this, right? Is it okay? You can follow that, right? These are the examples, right? Time short, I am not explaining details. Otherwise, I would done it, right? So if you're looking for implementation point of view, so you have to like activation, loss function, optimizer, and output layer configuration. So activation always use nonlinear inside the neural network. Loss function you should use any regression loss, but at least you can use the mean square error, MSE as a loss function, optimizer, SGD or Adam optimizer, and output layer of the model when you are building design that you should use the linear activation, right? Linear activation means fz equal to z, okay, where z equal to wx plus b, right? These are the mathematical things to get more on implementation steps for regression task, value activation, MSC, SGD, output layer, right? Then come to the Bani classification, you see that simple example, scatter plot of data, right? Blue color belongs to the 0 class and yellow color belongs to the other class, right? These are the set of examples you can explore in medical field by blue colors, right? You can use that for various application in healthcare field. These are the examples. You already have seen that, like brain tumor detection. Then you see the COVID, non-COVID, classification task. You can do that, right? Then these are the set of things for implementing. Keep in mind. So using the only that loss and output, these need to be changed. Rest everything should be the previous, for regression task. Activation and optimizer you can freeze. Loss and output layer based on the application. In Banach classification, you can use BC, Banach loss entropy, and output node you should use the sigmoid activation function, right? Because it gives you the probability for the class. But again, it will give you the number between 0 to 1. After that, you need to apply thresholding, right? Greater than 0.5 belongs to class 1, right? Or else class 0, okay? Normal things. So this is example. This is example of multi-class, right? You can see 3 classes, blue color, green and yellow here. And these are the set of examples which give you the deep applications like medical field. But these two are the uses in general applications. So medical diagnosis you can do subtype, right? Other field also you can do. Let's give you the detailed applications. In a histopathology, this is one application is called breast cancer, subtype division, grading part here. So if you see benign case, there are 4 subclasses, right? And each case has accuracy, recall, precision, and average image, right? And likewise in the malignant case, there are 4 subclasses. The accuracy, precision, already everything are improvable, right? If you see the average, still there is a scope for improvement of the result, right? In this case. And this is a data set which called BREC is available, and you can refer this for the breast model, right? And this was a data set was introduced in 2016. So breast cancer, this data set was the first data set which was released in the histopathology domain for AI integrations. And after that, that the research started AI with other, histopathology like liver, kidney, and all the things. So this part, this image already you have seen that different type of retinal disease classifications. This other example in histopathology domain, like is called colon image, basically glands. So first 2 are the benign, other 2 are the malignant case. So you can see that there is a called variables and touching glands treated as a single class, right? So role of AI algorithm is that to segregate that, where is the touching, need to segregate that, right? For that, if you see the bottom rows, so here there is a touching got segregated. So you can say there are 2 different glands, right? So that pathologists can take a right decision about the glands, right? And this is how you go for implementation. So loss will be using for critical cross entropy, and output layer you have to use the called soft max activation functions. I hope you are aware of that, all the things here. So these are the set of data set available, histopathology segmentation data set. And this is what the liver data set is available, which we have done with the KMC Mangalore collaborations, right? This data set is available on, just visit this link, you get the code, data set, everything is available. These are other data sets which could be used for the medical segmentation, all these. I mean, these are the list of, if you see that image-based classification, right? These are some standard models, and then you see that research. And if you say LiverNet, 2.x, this is what we have used from our lab, right? Medicaid, right? Green color. Likewise, you can do the pixel-based classification, right? Segmentation task. So we have also done some good model for the histopathology domain for doing segmentation task. Other part you can skip part. So this is how your grading part happen. CAD system, automatic, general system, right? Input data, pre-processing, segmentation, feature extraction, classifying, and then cancer non-cancer. This was the traditional way of designing the CAD system before deep learning algorithm, right? But since we have a deep learning algorithms, you can club everything, right? Segmentation and feature extraction, you can be clubbed together. You can give input immediately and you can do state forward feature extraction and all the things can happen automatically, right? This you have seen that all things. You see that, what you see here? Same liver organ, right? Is scanned by the two different sensors, two different basically the microscopy, right? So you can see that, what do you observe from here? Anyone can tell me? Student? Stand up and just tell me, what is your inference from this? Looking these two slides. Stand up and tell. What to tell? Stand up. Okay. So if you look at the scan image, right? This is darker side, right? And this is better image, right? Why it is happen is that every microscope, this is called optical sensor, right? Like your mobile phone, every mobile phone company changes. Quality of the picture changes. Why changes? Because of the sensor, right? Pixels, right? Same things happen here also. That optical sensor used, right? So that's why that same tissue is scanned by two different, microscopy. You get different quality of image, right? But what pathology will do? It doesn't have any ENC, doesn't have the, the knowledge of the optical or things instead, right? ENC is just looking only the image. See that this is not good quality image, right? Very difficult to make any decisions. But this you see that, okay, something can be analyzed, right? No. So one more step called scanning color normalizations. If you want to overcome the sensor limitations, you can do as a one more pre-processing called color normalizations. So color normalization help to overcome the limitation of the sensor problem, right? So data you have to do color normalization, you can correct it that whatever you need if changes are there, right? So this is basically liver cancer subtypes. If you see that, we have brought it to SCC and CC liver tumor. SCC, these are the features. Most of the things are SCC only. Whatever you do, hepatocellular carcinoma, and these are again the grades G1, G2, G3, G4 here. G1 is the lowest and G4 is the highest, right? So 5 grades here there as per standard protocols, right? And these are the sample images of the KMC Mangalore, which we have done subtype. So basically the low, medium and high. Because it was difficult to find the sufficient number of the sample for the high graded, right? 3 and 4. So we would only get the less number. So what we did, we just merged it, grade 3 and grade 4, and that did project completed somehow. So these you can see the cellular changes in the hepatocellular carcinoma. So if you see each cases, you see there is changes in the what is called textural properties, image. So textural things get changes. even one histopathology organ, one other organ, there will be changes. There will be structural changes, right? Will not be same here, right? So these are the models could be used for that, right? What is listed over here. We have tried many things. Coming to the practical aspect, as you see here, so these are the steps need to follow if you are building a deep learning models, right? Collecting data from hospital, understanding pre-processing, creating deep learning model, training of deep learning model, testing deep learning model, performance evaluation, and testing of deep learning on the new sample. So if you follow all the steps which written here, systematic do, then you are doing a complete project, right? So these are the implementation framework. You can do that part. I'll just show you. This is what the lever model, what we did it actually. First model in 2021. Okay. So this paper, complete work done by my BTech student only. Everything done by the BTech student, right? So if you see the first name is here, Anrudasu Kartres, Kumar Alapya. This is Jyoti Kini from KMC Mangalore Pathology Department, right? So from data collection, creating patches, everything done by the BTech student only. Writing paper, I just suggested guided, corrected paper. Rest everything done by all the coding to them only. And this was the first end-to-end deep learning model for the liver cancer grading. Right? There was no work available for the liver case. That's what the unique thing was there. And then we have extended other work. You can use the recent model also, but I will not speak much for that. Okay. So if you see that the model which already LiverNet was there, so average test accuracy on the KFC dataset was 90.3 and on the TCCA was 97. Number of parameter was 73,936. But this model was not very good models and result was good, but not as a efficient model. Then there is a other, I'll not go for this part, just skip it. So then later on, other group came up and they also come up with model called 2.x model. So here you see that 2.x model which improved the result of the previous model, 91.14 on KMC dataset. TCC was remain same, but the parameter was 2,73,000, right? I mean, even then less than 50% of the previous model. So this was an even better model and got published in 2023 here. And this is just quick. I'll stop in 2 minutes. This is my lab, right? So I'm the group head of this lab, computer vision and deep learning. And these are the significant projects which completed in the medical field, which you can see over here. These are the outcomes of the labs, different papers. This you have seen that this is a Nature paper on kidney cancer. We have done that. Apart from this, mainly we also work on the last year, other work on the prostate cancer. So 2 paper already has come published, right, in prostate cancer grading also. So our unique work was the liver, which was the first, followed by the kidney, and then followed by the prostate, right? Because breast case we did not want to jump because already it was many researchers they have worked in the previously, so they do not wanted to jump that side. That's how we working in the colorectal cancer as well, right? So that's all. I'll this one slide as a future direction is still medical field is an evergreen research area. You can do good project. You can make your career as a medical expert, AI data analysis, right, by using the medical data. you can make your future maybe better by using the medical data and integration of AI algorithm. And these are the medical other fields you can do, histopathology and all things. With this, thank you all for listening. Any questions there, I can take it. Because time is less. To my PPT, same PPT I can speak entire day, right? Entire day you need to listen the complete PPT, line each digit, but time is there, some of things skips, but at least you need to understand in a broader way. Right? Think first broader perspective, and then later on you narrow down, and then start working the future. Okay, thank you.
Thank you, sir, for your most relevant and informative speech on advanced deep learning algorithm for liver cancer severity grading from histopathology images. Thank you once again, sir.
I request Dr. Suresha D, HOD CSE, to present a token of gratitude to our chief guest, Dr. Shyamlal.
use of 3D computer vision and medical image processing. His skills also extended to biomedical signal and image analysis for healthcare design, demonstrating his commitment to leveraging technology to improve healthcare outcomes and address real-world challenges. His dedicated association with the Manipal Institute of Technology spans over 14 years, a testament to his significant contribution to the institution's academic excellence and his unwavering commitment to its growth. Throughout his career, Dr. Ravindra Yu has been consistently recognized for his innovative work and scholarly achievements. On behalf of the Department of CSE and allied branches of SIT, I extend a warm welcome and our heartfelt gratitude to you, sir, for gracious accepting our invitation and for sharing your valuable time and expertise with us today. Thank you, and we welcome you, sir, to this occasion.
Thank you, ma'am. I kindly request Dr. Raghavendra Yu to deliver keynote address on the topic Role of AI in Healthcare, Current Trends and Future Perspective. Over to you, sir.
Good afternoon, all of you. I know you have gone through the details of one of the CAD tool in a previous session. So my topic is going to be a little more broader. Start with the basics. We'll not spend much time on it. Later I will slowly come to our current trends in that and again deeper into it, what are the recent developments, what are the future plans, if you would like to take this field as a career path. So as you know, I'm talking about the role of AI in healthcare because that is my area of working for development of some early detection schemes and similar to the earlier speaker, but I'm going to be a little more deeper into it because if you can see the current challenges and the trends, we have a lot of things which are in place. So how differently we do, that will show us how we can, how the community will accept our work. So I'll try to collect or cover the topics which are new to you and which can be an eye-opener for the future work. So if I consider this an overview, you can see where and all I can consider AI. I don't think any area which is left out in this particular picture, right? Almost all AI is reached, all the sectors of in a day-to-day life, but I'm concentrating on the healthcare part. But though we have a lot of work which is existing in the market, the first question is, can we trust on these methods? You have to start our journey with that question. Let me think, because I cannot answer all these, whether all these systems which are already existing will work and whether we can trust them. But I concentrate on my area wherein healthcare sector, and we'll see how the existing system and also how we can validate it so that people will trust our method. So I'll set a preamble for my talk today because I'll put a boundary for my talk so that I will not go beyond that. I'll be there within that scope. With a single statement, is the healthcare industry is changing drastically, wherein the key player is artificial intelligence. If you take any healthcare sector, the major role of AI is the must. So what is the change in that? Integration of the artificial intelligence is rapidly transforming various aspects of healthcare, leading to notable trends in diagnostic, treatment, operational efficiency, and patient engagement. I'll be there within the scope for my presentation. This is my preamble, how we can do that, what are the limitations, what are the future challenges. All of you are aware of this, right? This diagram is very familiar to you, especially you belong to computer science background. Starting with AI, go deeper into a machine learning, go deeper into ANN, go deeper into a DL, right? So now what are the difference? Which one I have to select? Always people, because even in our lab also people are coming and asking us, which one is the better one? We too don't have the answer. Because we are doing a research, we are not doing any project, right? Because unless we do our effort or we put our effort, we'll never come to know about its results because we are doing a research. Hierarchy says it starts from AI and it ends at deep learning. But I tell you, that's not the end. Actually, deep learning starts your journey. Because that shows the way or a path for you, which method you have to select for a project. A technique that enables machine to mimic human behavior is all these four. How we can do it, how complex it is, we'll see. This part is also very clear to you, right? Machine learning. What do you mean by machine learning? Can anybody tell me definition of machine learning? Computer science people? Because I don't know still the definition of machine learning. That's the reason I'm asking you. If I get an answer from you, I'm so happy to continue that statement and tell all my students this is a statement for a machine learning. What is the definition of a machine learning? I have put something. I have input, I have a machine learning technique and the output. Do you think it will work with this data? Or if you get, because people used to present a paper and people used to publish their work with this many accuracy, this many precision, this many recalls and all. But how best those methods are. Now, let me put this into three different categories. One is supervised, unsupervised, and the last one is a reinforcement learning. You are aware of it, right? What is the supervised learning? We have labels, right? We have labels for it. Can you give an example for the labels? What do you mean by labels? The true value of it, right? True value. If I know the true value, I can predict it tomorrow. For example, I'll introduce somebody to you today by informing all the things about him. Tomorrow, in my absence, you should be in a position to recognize it. This is simple supervised learning method, correct? Because tomorrow I will not be there. Yesterday I have introduced somebody to you. You should be in a position to identify that person in my absence. If you are able to do that, what I can say, I have done the training properly. Correct? Yesterday what I have done? I did the training, today is the testing. Same thing applied in your machine learning as well. But I will give you one example. I have introduced person A today, and the person is facing towards you. Tomorrow you are able to identify. I will introduce person B today. Again he is facing towards you. Tomorrow I can see him from a corner. Are you able to recognize him? Partly, partially. But whether that partial thing is accepted here? No. What is missing over there then? What I have not done? I have not trained properly, correct? I have not trained properly so that my system doesn't know the another pose of a person B. Correct? This is the simplest example. This diagram may say a broad general diagram for you to understand a machine learning, but there are a lot of things which are not there in this diagram. That part you will come to know when you start working on it. The simplest way is the same thing, person B with a different pose. Or yesterday when I introduced, there was a bright light. Tomorrow, when you recognize him, there is a dark light. There is no proper lighting or sunlight. You miss, right? That is the reason. Whatever you develop, you ensure that learning is happened properly. With all the direction, please ensure that the learning is happened in a proper way. And this unsupervised learning, anyway, you know, we don't have a label. Then how you can learn? When there is no label, when there is no information about whether he is a person A or person B, how supervised learning or unsupervised learning will help? How can computer science people or students, can you tell me how unsupervised learning really works? How it works? There is a statement you can read, discover a hidden pattern in unlabeled data. Do you think it is so easy to do an unlabeled part without labels? No, it is not that much easy, but in some cases, when there is a completely overlapped data, we can predict properly when we use unsupervised learning. We will come to that part later. This is a very broad diagram and a broad statement. And reinforcement learning learns action through rewards and penalties. Again, it is an iterative one, right? Now, out of these three, which one you select? Supervised learning is the one because it's the easiest one. I know the class it belongs to, correct? Now, can you able to apply the supervised learning in all the applications? Do you have labels in every and each project? No, we don't have. Sometimes we have to do the second one first, this unsupervised first, then we have to come back and see the supervised learning method. So, it's purely based on the application one. And the deep learning one. You are aware of deep learning one. I will not cover much on the deep learning part because of my previous presenter, he has almost covered this deep learning part, right? Can somebody tell me what is deep learning? What is deep learning? Again, I confused with the deep learning. I don't know the statement and the definition of deep learning. Somehow I have put something for you. What is that? DL is a subfield of ML that uses artificial neural network to analyze complex data, particularly unstructured data like medical image and the clinical notes. Because there itself we have mentioned the challenges. What is that? Particularly unstructured data. Unstructured data. Now compare ML and DL. Which one is the best? Which one is the best? ML is the best? Or deep learning is the best? Deep learning is the best. Can you raise hands, those who says DL is the best? Because I cannot say whether ML is the best or DL or GenAI. So many things are there, we'll come to that part later. But I cannot say, I cannot generalize those methods unless I test it on a particular project or a database. Because we observe that deep learning will perform poorer than a machine learning in certain cases. Because deep learning requires a lot of understanding. That is the reason we are calling it as a deep understanding or deep learning. Right? When there is no deep learning happening during a training period, then actually deep learning will perform poor than your machine learning algorithm. Or when a sample size is too less, we cannot expect good results in the deep learning methods. So this part you are aware of, right? This is a neural network and how we can make it as a deep neural network. What we add here to make from a neural network to deep neural network? What is the addition we can see here? Hidden layers, right? Now, think that you have only one hidden layer and you have a 10 hidden layer. What is the difference? What it actually does? See, because you have studied the hidden layers and this neural network, right? Tell me, what is the difference between the single layer and the 10 layers, 10 hidden layers? What it actually does, how it impacts your network. What do you mean by adding a hidden layer? In a simple sense, I have an image of size 256 by 256 for a single layer. What I will do, I take a small portion of it with the dimension of 48 by 48 pixels. Now, I'll add 10 more hidden layers. What will happen to this 48 by 48 pixels? Whether it will be enlarged or it will be narrowed down into a smaller pixels. What will happen? It will reduce to a smaller pixel. When you reduce to a smaller pixel, what actually affects? For a single apartment, I have a 1 security guard. For a single apartment, I have a 10 security guard. What is the difference? Huh? General question. I'm not talking anything technically, right? 1 apartment with single security guard, same apartment with a 10 security guard. What's the difference? You have a closer look into a scenarios or environment, right? When I add more and more hidden layers, what will happen? You go deeper into it and you have a small portion to concentrate. Suppose think that you are developing an algorithm for identifying a cancer is in an early stage, because what we are doing, what we are working in our lab is not a detecting and the segregation of the data. We are working on an early detection scheme of it. What are the early signatures which we can capture it in a very early stage before the cancer go to a level 1 or level 2. That is the work we are doing. Now what is the difference now? If I add more and more, I have a closer look into the pattern, right? So that I can extract more signature out of it, so that even a small portion can be captured using my algorithm. That is the hidden layers importance, right? So, rise of big data in healthcare. Now what happens? You just imagine, because we are attached to a Kasturba Medical College and Kasturba Hospital, Manipal. And you know the patient level and the incoming patient or OPD patient every day in KMC hospital, either in Bangalore or Manipal, right? So, now the thing is, how can we combine all this data, collab all this data and do our work? What happens? For example, I want a blood test report of a person from last 10 years. Similarly, I have to arrange for 1,000 patients. You just imagine the data which I am gathering. Automatically what happens? We have a very huge data which cannot be processed either through any systems or workstations. Then what we require? We require a dedicated space. Correct? Where we have to upload our data and we have to access that data. That comes in a big data and healthcare again. Why it is required? Because we are dealing with a large number of data. For example, I'll give you, because we are working with the ERDs. I think you know ERDS is a acute respiratory distress, right? It is a lung-related one. Because of that, there is a problem for breathing. Right? That is ERDS. For that, we are working in our lab, we are collecting almost 500 features of a single patient. Because when a person is having the ARDS, he will be admitted for a hospital for more than 5 to 6 days. Every day they have a multiple test. And all those tests is required for us to understand and predict. Now the project outcome or the aim is, a hospital like Kasturba Hospital, we have multiple units. Units in the sense a group of doctors, they look into a certain number of patients. When a doctor comes in the morning, suppose a unit is having 25 patients or 30 patients with the ARDS. Now what happens? He has to manually see all his record, a patient's record from a day one. Few patients admitted yesterday and few patients admitted day before yesterday. Just imagine how many files he has to repeatedly see. We are developing an algorithm wherein, as and when a person or a patient is doing some test, it will move to a big data or a cloud. Wherein all the data will be processed by an AI algorithm fortnightly or or every day night, then what happens when he or a doctor or a surgeon comes up next day morning, he can see out of 25 patients how many are improving, how many are deteriorating, so that he can prioritize his day to visit more into people who are deteriorating with the clinical treatments. Are you getting my application? This is the one which we are working right now. So out of 25, it prioritize and gives, see, these are the patients, high risk patients. These are the patients who are from last few days, we have given a treatment and he is improving. How we can do that? We need all the data of the patient, and it plays a very crucial role in identifying the disease and its improvement using a big data. Because we have a lot of data with us. So we need a cloud space for that. This is the role of big data in healthcare again. Now something interesting is a virtual and physical AI applications. I think you are aware of this part. Can you tell something about the first one which is there on the left? Which is a virtual. What is the virtual one? Virtual AI includes tools like EHR, it's an electronic health record, assistants, a diagnostic algorithm, and voice recognition system. You can see something over here. What is this? This is one something device which captures the data. This is an app which you have installed in your mobile phone. You are giving input to the data. That will go to a cloud and decision will be taken and it will feed back to your app, right? Or an application. Compare it here. What is the difference? Here, because he will be treated or he will be scanned for some human organs, automatically it will come to the system. There is an AI hidden into the system and a surgeon can take a decision. But here what happens? The data is there in the cloud. Are you getting my point now? What is the difference between the virtual and the physical AI application? Because here the intelligence is in cloud, here intelligence is in the system. Because you cannot give intelligence to a patient, right? You can give an application to a patient wherein he can put a data. For example, if you're developing an API or an application and install it in a patient's mobile, and you can ask him to feed, for example, if he is able to measure a blood sugar level, he can feed that amount, right? Or the value. Only a decision can be taken either by a cloud space or the expert. But here, the expert is in front of the system. So that is the difference between two methods. Because I am taking these parts because these are the new development in the area, not the one which is existing. Now we'll see some of the current trends. I think my previous presenter has highlighted properly about this chest X-ray part. Because one of the challenging modality or imaging modality which we deal is X-ray images. What is the difference between X-ray images and MRI? The resolution, right? There is no contrast, there is no proper resolution. So it's very difficult to analyze any of the X-ray space. So AI algorithm analyze X-ray, CT and MRI, ultrasound to detect disease like cancer and fractures and pneumonia with high accuracy. Deep learning model excel at image pattern recognition. That's the reason I said, if my modality is a CT or MRI, at up to a level I can use a machine learning algorithm. If it is an X-ray, then I have to go for a deep learning algorithm because as I said, it will go deeper into it and it takes a smaller component to understand and make decisions. So this is the one which commonly we call it as a computer-aided diagnostic tool development. Right? This is a common general diagram, and I have dedicated it for Alzheimer's disease. What do you mean by Alzheimer's disease? Any idea? What is Alzheimer's disease in general? Related to the brain. More specifically, it's a memory, right? How I can identify that in an early stage? That is the work we do. Because there are already working models which can detect this Alzheimer's disease in categorize them into Alzheimer's, non-Alzheimer's and all. We are working with some kind of a early detection scheme, but this is a general diagram of what I am telling you and showing you. This is a image one, this is a actual CT images, or you can use it MRI also. So image segmentation, then segmented feature extraction and image recognition in the Alzheimer's disease. This is simple diagram. What is the complexity involved in it? Do you think it's going to be a very simple method to detect this Alzheimer's disease in an early stage? Because we don't know the very early signature of it. If I know the signature, for example, a brain tumor, I know how the brain tumor looks like. But in this case, I don't know the early signature of Alzheimer's disease. How you can do it? What is the method? Because one of my BTech student is working on it, and we are able to identify some of the early signature, which our clinician says, yes, this may be some of the early signatures. Because we are giving the signals of our students. Because one of our funded project, we are working for a EEG analysis, emotional intelligence. Wherein along with that, we are taking the signals from this also. To see is there any early signature wherein maybe in next 2 to 3 years he is going to slowly lose his memory. Right? That early signature we are trying to capture. But it is not that much easy because we don't know what are those early signatures. Identifying those early signatures is the breakthrough for a healthcare sectors. Right? We are working on that. Again, the rest, if you see almost all the common sectors, but identifying these features in early stage is the one which we really require. This is again a predictive analytics in a diagnostic. This is a more general one, not the earlier one, because you can see the electronic health record, EHR. As I said, for most of our existing projects, what we do is we are taking data from all the directions. Because in earlier days, we were unable to add some of the features like your blood test, because blood test is a value, correct? It's a number. And your ECG signal, it's a signal. And if you add some of the ultrasound images, it's an image. Now, the trend is towards a multimodal thing. We can add any number of modalities to our system. That's the reason we are using, because we are working for another project, because people used to say this heart attack is due to the one vaccine which we have taken. So people are interested to see whether it is really true or false. We are working with that because ICMR is also working on that, and ICMR said there is no such signature with which this has happened due to a vaccine. But we have a lot of data in KMC. So we have started collecting data. We have around 5,000 patient data. Those are having or those who have taken this vaccine, for example, Covaxin and Covishield, and they are coming to a OPD of a cardiology with the heart-related diseases. We are taking such a data and we are trying to find out any early signature. Here also we don't have any clue. We are clueless now. We have to identify that clue which results in a heart abnormalities, but again it's a challenging one. Because see, this is an electronic health record is maybe on paper in some of the hospitals, how we can digitize it, right? That's the one first challenge. Second is the clinical notes, because doctor used to write something about his opinion on some of the records or a test. For example, blood test or maybe a blood sugar test. They used to write it on a paper, how you can convert it into a number and give it to a system. Next is the wearable devices, because some of the catheters they put for our cardiovascular disease related patients, and it will record something every alternate hours or for every 4 hours and all. How can you bring that value into a system? Next is the public health records. For example, your earlier one, because usually we have a MRD, medical record repository or a depository, wherein we have all a particular patient earlier records. How can you digitize them and keep it in your system? After that only data collection comes, because you collage all and send it to a data pre-processing technique, because he is a challenge, because we don't know which pre-processing method to apply, because we have a number, we have a text, we have a paper, we have so many other things. How can you apply one single processing method for all these data? Next is the prediction model. Again, your prediction model is to accept the value which is acceptable to the system as well as for the community. Then later part you can see we have early detection scheme which we are working, and we have a personalized treatment which we can send it to a patient, and we can have a risk prevention which will go to only the doctors. This is the three way we are working because it is more advanced than a simple computer-aided diagnostic tool. Correct? Next, this is a personalized medicine with AI. This is a very new development and very interesting part. Because you don't have to keep a doctor always with you to assist you in certain changes in your clinical or health parameters, right? So you can see here, it is connected to, a person is connected to so many things and so many networks, right? You have all the big data, you have all the AI modalities in it, and you can see AI supports personalized treatment by analyzing medical histories and genetic data and clinical record to tailor therapies. AI can predict how patient with specific genetic profile will respond to certain medication, because this is a very interesting one in the current trend. I'll come to that part later, how you can develop it. But this is the current trend, personalized AI methods. Because if the personalized AI method will identify whether the patient is in a very high risk or a low risk. If it is in a low risk, AI will suggest you to do something. If it is in a to a doctor. Next is a drug discovery and development, how AI can be used. Because AI will help both in discovery as well as in the development. How? See, AI can analyze data from clinical trials to uncover previously unknown side effects of drugs, enhancing patient safety. Because AI will not forget anything. Being a human being, we can forget some of the things which it may be good or bad, we will forget. But AI will take that as a future memory or a previous memory, as and when required, insert that previous record. That's the reason I have included a statement like previously unknown side effects of a drugs. It will help you to discover a new drug without any side effects. And also, it will help you to development of it. AI being used to identify new therapeutic uses for existing drugs, a process known as a drug repurposing, which can significantly reduce the time and cost associated with bringing new treatment to market. It helps reduce time and cost in R&D pipeline, because nowadays most of the logical decisions which are there in the R&D labs are getting replaced by AI solutions. One of example is a drug discovery and development. One more interesting is new development is a virtual health assistants and a chatbot. This is the one very interesting thing. For example, usually what happens if you have a query with respect to some, for example, I'm developing some device which can detect heart rate for every 4 hours. I'll send that product to a customer, and customer has a lot of query on that. For example, every 4 hours he gets his heart rate, right? He has a lot of query. Do you think I'll sell around 1 lakh product every month? Can I able to answer everyone's query about every heart rate measurement? No, it's not possible. Then your chatbot will come into a picture. How we can do that? We have a set of queries. We have a set of answers to it. I'll ensure that my Gen AI will understand those and develop a model. As and when a customer asks for a question, it will fetch answer from a memory and give it to you in absence of an expert. Right? That is the one which we are discussing here. It's a virtual healthcare assistant and a chatbot. You can see this is a more generic information because I have given it as a signal one. Similarly, I can use it for any type of data for a chatbot development. This is AI in robot assist surgery, because this is one very interesting one. Using a surgery, using AI, we can go for a surgery as well. But the question is, what is the precision? Correct? Because precision is the one which, because we are not dealing with any artificial toys or something, we are dealing with the patients, right? Then precision is the one which is plays the most important role. Now, you can ask me how efficient these surgeries are. Those purely depend on my first example of how I train them, correct? How to train them in a proper way so that the accuracy and the precision will be very close to the true value. Now, you can see some statement here. AI algorithm analyze surgical field images or real time to identify critical structure such as blood vessels and tumor, aiding surgeons in decision making, but they are not doing the actual surgery. Correct? They will take a decision whether to go for a surgery or to remove any organs. They provide real-time data and decision support to surgeons. AI helps in creating patient-specific surgical plans. Give you a plan. But there are certain things, a new development in this area wherein it will do a surgery as well. By multiple trials they have conducted and they have got a certification from a third party as well so that they can do a surgery. Again, a precision is the one because robot is inserting some catheter into an organ and you should know the exact distance between an organ and the catheter, then only you can do a surgery, right? In such cases, precision play a major role. Still, people are working with AI to make that precision very high. Now the consolidation of all the AI development for a healthcare. What are those? Diagnostic and early detection. You are using medical images. Personalized medicine. You are using customized treatment plans. Drug discovery and development, identification of a drug or candidate drug repurposing, operational efficiency you can improve, virtual health assistance, robot-assisted surgery. All these are having its own limitation. Please don't think that whatever we have consolidated will give you 100% because it is not a human decision, it is an AI decisions. But we have key benefits, I have listed key benefits as well. Improved accuracy, more effective treatments, faster development, reduced administrative burden, improved patient access and a faster recovery. Yes, we have advantage, but it has to be tested on a huge large data samples. Now, what are the other some applications if you are interested? So it's AI in medical education and remote patient monitoring, ambient listening and documentation automation, AI-enabled variables in healthcare, AI in fraud detection and compliance. Especially because the last one is a little interesting. People are interested to apply this in especially medical records. I'll skip this part because I have more interesting things to show you in the later slides. Now the very basic diagram, I think even my previous presenter also, he has presented a general diagram where CNN and RN are used, right? And I have given you example also. What happens if I use more and more hidden layers so that this tumor, non-tumor thing will become more and more accurate when I make a more hidden layer. What is the disadvantage of it then? Why people are going with a single layer? Or a 2 layer or 3 layer instead of 10 layers. What is the difference? What is the advantage? Using a multiple layer or a 1 or 2 layers. Anyway, I know that it is going to be a classification or a decision or a severity assessment is going to be not so accurate. Still people are using it because it's a time constraint. Because when you go more and more hidden layer, it takes more and more time to give a decisions. But people are still have a solution into it. They are using a workstations, right? Or they are using a cloud services. Google Colab they use so that they will be and with the premier version so that they can process the images or a decision very fast. I'll go to the next stage. It's a transfer learning one. This is a one new development, a deep learning method. What is the transfer learning? What is transfer learning? I have already learned. I'm transferring that information or my knowledge to another task. You can see here, we have two things here, right? One is the first task A and task B. What is the difference between the input data of task A and task B? Can somebody tell me? Because this is one of the new development in the area. You should understand this if you want to take up any projects in this. What is the difference between this image in a database and the medical images? What you can see here and see here. You feel like this is a garbage, right? But still people are using it. What? It has information, right? For example, see, I have trained my network with some garbage, but still I have some information to me so that I can use it for one particular images. Because this medical images are just X-ray images, it might be there in this garbage. This is called a pre-trained network, what you are calling. Correct? You have trained it with some of the database. It's a totally a mix and the mess with what? With those databases you have trained it. Now you are trained properly and it can handle any type of images. One such image test data is my medical images. This is one of the very recent development in a medical imaging for a AI in healthcare. It's a transfer learning method because we have written one review article in 2022 and it has got 388 citations within the last 2 to 3 years because the reason is the trend is now transfer learning because you cannot train your model only for a certain set of images. The thing is you cannot use it for some other methods. So second thing is you cannot train it with so many samples. We have a lack of a sample. That's the reason transfer learning is getting very popularity now. This is autoencoders. One more methods. What is autoencoder? Can you see any hidden layers here? It has hidden layers, but there is no specific labels. Correct? But you have an encoder and a decoder. It encodes the data, and you have a hidden layers. At the end, it decodes the data, but there is no labels. But in some applications, these autoencoders are also working very efficient than a deep learning methods. Next is the recent level. This is a very interesting part. Now, you can see a lot of papers published in healthcare domain in various diseases. But the missing part are the one which I am going to tell you now. What do you mean by ablation? Do you know the meaning of ablation in clinical science? What do you mean ablation? If I ask a doctor, he'll tell me ablation is the one removing some organ from a human body. And see how body reacts. That is called an ablation in a medical science, not with respect to engineering science. Now, how come that ablation is important here? You can see one example. I have developed for example, I have developed an algorithm which will tell me whether the input image is cancerous or non-cancerous. And finally, I'll get some accuracy. I'll publish my paper. But I'm not going to look into the pattern wherein how many of my, for example, I have received a 95% of accuracy, for example. What is it? 95, what is the meaning of 95% of the accuracy? What is the meaning of 95% accuracy? My model identify whether it is a normal or the cancerous up to an accuracy of 95, right? That means that I have that 5% which is a failure cases. Now, have you seen any method which says out of this 95, 10% are actually normal, but my algorithm detected it as a abnormal cases because they were on a border case. This is the one which requires attention. And this is the one which really doctor wants. That is the reason what happens, most of the doctors, they will not trust engineers. Because we show them only the numbers. What they require the outcome of it. Here we have a method, it's a recent development, we can, if you want, you can work on it. It's an ablation study. Nowadays, without ablation study, you cannot publish any papers in a high-end journals or given articles. Now, what do you mean by ablation study? See, I have developed a model. I present that model into 4 different things. Model A, Model B, Model C and Model D. What is the difference here? Out of those models, you can see in the Model A, Module 1 is missing. Correct? Module 1 is missing. In 2, Model 2 is missing, and in Model C, Model 3 is missing, in Model D, Model 4 is, or Model N is missing. What I am going to do here, what actually I am doing, think that Model 1 is some kind of a blood test. Module 1 is module 1 is some kind of a blood test. What I am doing now, in model A, I'll remove that model or a blood test value and I'll test my model. What it shows, what is the importance of that blood test in my decision making, correct? Similarly, in model B, I'll remove module 2, that may be some kind of ultrasound image. That I'll remove, I'll test it again. Finally, when I complete this all, model A, model B, model C, model D, what I'll get? Clearly get the picture, which is the one which is most important, which is not missing. Because for every time when you do a remove something module 1, any one of the module and test, you have to see how it is affecting your model. That means how much performance of a reduced by removing this. This is called a ablation study. Some of the details I have given. Why it is important is it ensures robustness, identifies critical input and avoids overfitting to irrelevant patterns. This is the one which really requires for AI algorithms. These are the key steps as I explained. See, establish a baseline without removing anything. You run the model and get the values. Then systematically remove elements. Drop one feature group, remove model layers, test alternative architecture, and re-evaluate. That shows you whether if you again get a 95%, then I will say that your model is perfect. Correct? So next, visualize result, use a bar plot or confusion matrix to illustrate performance changes. Next, very interesting thing is uncertainty. What do you mean by uncertainty? In general, what is uncertainty? Probability. Any other answer? In general sense, what is uncertainty? Complex? Unexpected thing. Can't take any decision. Correct? What do you mean by that? I am in the border now. Correct? I should get a help from a doctor only. Only doctor should tell me whether it is because I am on the border now. This is neither normal nor abnormal thing. So in such cases, who should help us? Only the doctors. What we are trying to do, we are trying to replace a surgeon up to a level. But again, we require help from a doctor. These are all called the uncertainty, because these uncertainties are the one which plays a vital role in the recent days. So how you can do that? It's a reliable decision making, quantifying the confidence, ethical consideration, and robustness, scientific advancement, risk assessment, resource allocation. These will define your uncertainty. If you overcome this, it's going to be a zero uncertainty. Now, what is uncertainty in AI prediction? What and what? Again, the same example. AI model can make confident but incorrect predictions. I'm threatening my own work here. Correct? Because I'm working in this field, I'm threatening this now. AI models can make a confident but incorrect prediction. In such cases, can you trust any AI algorithm? Then what is a must? Uncertainty analysis is a must. Please remember this first statement. AI models can make a confident but incorrect predictions, especially with unfamiliar data. I'll come back to the first example. I have introduced person B with the clear straight force. Next day, it is going to predict it as a person A with 100% confidence, but actually the person is B. That shows the uncertainty. Because I'm again and again giving the same example so that you can relate. So next point is two main types as allotoric uncertainty and epistemic uncertainty, because comes from a noise in data, the first category, because I'm using with the data, right? Input is my data. There may be a noise in the data that may create uncertainty, or comes from a model ignorance. This is the most dangerous factor. Anyway, in most of the algorithms, we are doing a pre-processing test or pre-processing technique, which will most of the time remove the noise. But the second part is the most dangerous part. Think that the person is normal, but you have identified and suggested to your surgeon that he is abnormal, he is having a brain tumor. See the situation of the patient. Or other way, he is actually in a abnormal case, but you have your AI algorithm predict it as a normal case. That is even more dangerous. Correct? All such things should be handled using uncertainty analysis, because you are not getting this more detailed uncertainty in Google, because you can see only the recent articles. So next, use cases in tumor classification, high uncertainty alerts. Radiologists to double check the borderline cases rather than relying solely on AI. See, this is actually shame for an AI engineers. Correct? Because if I require a radiologist to tell me whether it is a normal case or a normal or abnormal, then what is my role? So uncertainty plays a very important role. How do you measure uncertainty in healthcare in AI? Again, this is Bayesian neural network, Monte Carlo dropout, and confidence intervals, calibration. These are the very recent methods you can explore, which will tell you clearly whether how many uncertainty. Because I have to run entire model and have to run it with the uncertainty analysis. You can see the difference. If your result drops, then you can say that even if it is a 10% lower than the previous value, but you can say that confidently that my algorithm is 85% perfect result. Right? That is the uncertainty analysis. These are the key methods which we usually do in our algorithm, because nowadays what happened in a technical domain is without uncertainty analysis and evaluation study, people are not accepting your article, especially in your quarterly wine journal, because they want to see how confident you are about your model. Next is the transparency and the explainability in AI. I think how many of you heard about this explainable AI? Raise your hand. Explainable AI. What do you mean by explainable AI? Can you read or can you see the figure on the top left or the right and tell me what is explainable? See, initially he has how? Because have trained my model, have sent one image for a testing, and it is showing it is a grade 1. I don't know how. Correct? Now the situation is, I should accept whatever AI says. I have 100% of confidence. See the situation, my situation over there. I've tested it, I've sent for a testing, it says it is a normal case, no need to worry. My question is how? See the second one now. What is extra in the second one? And the person says, I got it. That means he came to know how it is normal. Do you think the existing AI system says how? No. That is the requirement of an explainable AI. It's a new trend in the AI algorithms. It says how it has happened. It will not orally tell you how it happened, but it will give you, for example, I have a set of features with which I have trained, right? For example, I'll come back to the same example. Yesterday I have introduced somebody to you by telling all his significance. For example, his features, he's having this much height, he's working there, and his skin color is this, right? He belongs, he has done this, he has done that, and all the information I have given you. Explainable AI will tell you, see, these are the values with which I have decided that it is a normal or a person A or person B. That is the explainable AI part. Those who are having interest in AI, please explore this explainable AI. Right? This is, you can apply all these explainable AI to all the existing models. We are doing that now. All our previous model which we have developed and published, we are applying a XAI now, and it says wherever we have gone wrong. That's the beauty of explainable AI. For example, you have used 10 features. It will tell me, see, look, this is for a test, this is the result you obtained, wherein only 4 features are enough and which are contributed to take this decision. That means remaining 7 are useless. Right? So that's the reason we are using XAI. Many high-performing computing models like deep neural network don't show how they arrive at their decisions. Wherein we have a technical solution called XAIs or explainable AIs, where multiple methods are available, but you need to understand it from the scratch to apply it. It's called a Shapley, we call it as a Shapley or SHAP. It's a Shapley additive explanations, which will tell you which feature really contributed to take a decision. right? Or a line is another one, as a saliency map in CNNs is one. The reason is why it's critical in medicine. Doctor need rationales for AI suggestions. Example, why a tumor is likely a malignant. Correct? Otherwise, you would have detected it in a very fast way. He will ask you, for example, if my AI says this is a tumor thing, immediately radiologist or a surgeon will ask, how? Being an engineer, we are unable to answer because my deep learning is a black box. But explainable AI will open up that black box and it says, this is the way I can say it or call it as a tumor or non-tumor. Now let me take a last part. I think I'm running out of time. So, future of AI in healthcare. I too don't know future of AI in healthcare. But somehow I consolidated with my statement, integrating cloud, generative AI and emerging technologies, because three are the three different directions. Correct? One is integrating cloud, because my data is increasing every day. I need a more space. And generative AI, because I have lack of samples, because if I want to develop some of the method for identifying cancer is in early stage, I need images in lakhs, because Google is working on an early detection of diabetic retinopathy with the lakhs of images. Then what is required? I need a generative AI which develops or generate synthetic images for me. How a Gen AI does, because Gen AI is a very big field, it understands again, it try to learn the existing thing and generate a synthetic data and give it to you. The next one is emerging technology. We have a lot of technology which can process the method, either EEG signal or images or medical records. So we'll see quickly, cloud plus AI is the one future. If you want to take up, you can take up projects in this. Scalable data storage and access, enhanced AI model training, secure patient data management. These are the very key areas which you can plan for your project or research. Generative AI for clinical workflow. This is the one key thing or experience we are facing in our lab. So we need automated documentation, virtual assistant, personalized treatment plan, because we are sitting in MIT and people are or patients are coming to KMC. We are developing some SIP so that as and when they do some treatment, automatically it will come and stored in our system. That is what a SIPs. We are establishing it in MIT now. So virtual assistants, even if we are sitting away from a station, you should be in a position to connect to them and give a virtual assistance. And the next one is a personalized treatment plans, as I say, shown in one of the methods, wherein automatically you can use a chatbot and give a personal assistance. Next one is a multimodal AI and digital twins. This is again one more future directions which you can concentrate for your research, wherein multimodal is a combination of text genomic, which we have given you here this example wherein we are combining data from different disciplines. That's the multimodal part, text genomics of holistic insight, signals, images, EHR records, etc. And the digital twins simulate patient physiology for testament planning, because we are using it in KMC. We already installed this KMC. We have a tool called some segmentation methods where you can see actual patients simulated data. Right? Actual patient simulated data. They scan up people or scan completely up the patient. Entire simulated data is available on a table, wherein a surgeon can simulate it, rotate it, or open it up and see the organs. Right? We'll call it as a dissection table. You can Google it. Dissection table is the one. Simulate the entire body part of a human organ. That's the one recent development, because it's cost around 2.5 to 3 crore rupees for a simple tabletop. Right? Wherein patient will be scanned and its simulated thing will be observed so that surgeon can take a more accurate decisions. So the final is, as I said, this is more interesting for me is a Gen AI part in the healthcare, because you can see a lot of things are connected to a person now. Now you have to decide which one to take, which one to reject, because you automatically it creates a sum of the chat. So next, as a conclusion of my presentation, I told you in the beginning, I'll be there within the scope. With that scope, artificial intelligence is rapidly transforming healthcare by enhancing diagnostic, personalized treatment, streamlining operations, and supporting both patients and professionals. While the future holds immense promise with innovative like generative AI, remote monitoring and digital health assistance, it is essential to address ethical and regulatory and trust-related challenges. Finally, with reasonable development and collaboration, AI can become a cornerstone of a more effective, accessible, and equitable healthcare system. And then this is my lab in MIT. We call it as Advanced Healthcare Research Lab. And these are my collaborators. They are very high profile collaborators. So now if I have any questions, I'll try to answer. Otherwise, post session we can answer your query. And thank you. If you have any questions, you can ask. Any questions from the audience or students or teachers? Otherwise, you can ask me any questions post session. Thank you.
Thank you, sir. Thank you for your enlightening speech. Truly, it was a great insight on role of AI in healthcare. I now request Dr. Shashidhara Kini, HOD